All right, so take a look at number 1 here. It says state the zeros and multiplicity for the function. How do you find zeros from factors? You see factors here. We got 2 factors. How do you find zeros from that? Very good, Makai. You just set them equal to 0 and you solve from there. Today, I'm not solving it for you. You can go through the process. But yes, you would just take your x minus 2, set it equal 0, and your x plus 1. And you would solve each one of those to find zeros. Question on this. It says multiplicity. What does multiplicity mean? The powers. How many powers of it does it have? And so that would be the multiplicity going off of that. How many times that 0 occurs? So in this case, how many times does this 0 occur? 3 times. And this 0? 2. Okay, good. So that'd be the multiplicity there. All right, when you get to number 2, it says describe the end behavior. That's talking about the limits. That's why it says using limits here of the graph given by this equation. And so if you're going to do that, what I suggested last class is to use the leading term test. Specifically, we need to identify what is the leading term in this equation. So I'm hearing negative 4x to the 6th power. Why is it not, this 6 looks like the biggest number. Shouldn't it be the 6 as the leading term, or maybe because it's first? Highest power. So it's all based off of this. So you could, obviously you can type it in the calculator, get the exact view of what that graph should look like. But you can actually base it off of this. You could go through our 3 strips about what direction is it, being first quadrant, first, fourth quadrant. You could do about what is it, the power, being a power of 6, does it curve like a C curve? Does it make a straight line? Does it curve to the y-axis, or does it curve to the x-axis? You can go off that. And then thirdly, talk about is 6 even or odd to come up with a drawing. But ultimately what I'm looking at, when you graph this, you need to write 2 limits. You need to write the limit as the graph goes left forever, meaning as x approaches negative infinity. And you also need to find the limit as x goes right forever, meaning x approaching positive infinity. You need to determine what's happening. Is the graph rising, falling, getting flat, or stopping at some point? So that's the answer you're going to be needing to solve for on number 2, if you haven't already. And then finally, number 3, you determine all real zeros. Again, you can graph this and look for them, or you could go through your factoring steps. All right, as we start this lesson, what we're going to look at today is, in particular, new ways of factoring. We've done X method, we've done GCF. I'm going to show you 2 other techniques that we can factor equations. That's the whole goal for today's lesson. 2 more techniques. Before I do that, I want to warm you up here. So on your packet, just in the white space on the front page right there, I want you to go ahead and write this out so you can just get in your frame of mind. I don't know when you learned this, maybe 3rd or 4th grade. When you first learned how to divide, and your teacher set this up like this. I know today, you probably just look at that and say, well, the answer is 4. Okay, but when you were first taught to divide, the questions that you would ask yourself is, how many times can 4 go into 1? Can 4 go into 1? Yeah. No, and if it can't, then you add in the next number. How many times can 4 go into 16? You just told me. 4. Answer is 4. And you put the 4 right there. I think that it does this. So I'm going to take that away and take this one away. There we go. Let's fix that. Okay, so it goes in 4 times. And so then the next step in the process is the part that a lot of students have forgotten because, frankly, you haven't had to do this in so long, is you take this 4 and you multiply it times the other 4. What is 4 times 4? 16. You put the 16 there. And now, would you add those together and write 32? No. You would subtract them. Okay, but what does it say to subtract? No, you just know to automatically switch the sign. And so what is 16 minus 16? 0. And when you're first learning division, you don't know anything about decimals yet. So after you've divided all the way across these numbers, we did 16 there, there's no other numbers. You would say this leftover number, you'd call it something that started with an R. The remainder. Does this one have a remainder? No, no remainder. Great. It went in evenly. So the answer would be 4. Okay, let's do this again. Let me erase that arrow there. Let's do this again. This time I'm going to change the numbers. What if I was talking about 5 going into 21? The questions you'd ask, again, get in your third grade frame of mind here. 5 go into 2. Can 5 go into 2? No, so you move on. How many times can 5 go into 21?
4.
Again, we got 4. So then you would multiply 5 times 4 and you would get 20. Okay, and this is the part I really want you to write down just so you can remember that this is actually how it happens. You don't add these together. That's a positive 21, that's a positive 20, but you don't add them together. What do you actually do instead? You would subtract. And so we would minus 20, and so we would say 21 minus 20 is 1. That's the remainder. If you have forgotten, you could write the, oh, by the way, what do you call this part right here? What's the name of that piece? The answer to division. Starts with the Q. Quotient. That's it. That's the, it looks like a, oh, let me try that again. Quotient. This is the quotient. Okay. If you remember, oftentimes you might also write your answer this form. You might say the quotient, and then you write the remainder as being divided by the divisor. That right there is the divisor. The thing doing the dividing, divisor. And so you might say this is 4 1/5. Now I'm going to give you one more. What if we were dividing 3 into negative 17? Let's go third grade here. Can 3 go into negative? Can 3 go into negative 1? Can 3 go into negative 17? Yes, it can. How many times does 3 go into negative 17? Here are 5, but the problem with 5 is 3 times 5 is 15. Keyshawn, you saying?
Negative 5.
Negative 5. Okay, because 3 times negative 5 is negative 15. Now I want to point this out again. This is the part, the reason the whole reason I'm doing this is right here. You don't look at that and say, oh, negative 17, that must be negative 32. What do you actually do instead? Would I subtract 15 like it says right now to do? You would add it instead. And so negative 17 plus 15 is?
Negative 2.
Negative 2. That's the remainder here. Okay, so I just wanted to walk you through on all of these. We switched the sign right there. We switched the sign. Why do I want to point that out? I'm going to call that the fundamental rule of division. Is that we're going to, when you actually go to divide and simplify your numbers, you have to change the signs. So I showed you basic problems because we're going to apply the same math now to complex functions. So today we're going to divide functions. And so the first technique we're going to look at is long division. So in example 1 here, it says to factor this long equation completely using long division if 2x minus 5 is a factor. Okay, I want to add some stuff to your notes. When you get to your homework on Alex, they might call this f of x. The function that's getting divided, function that's getting divided, they might call f of x. The 2x minus 5, that's our divisor. So I'm going to write that as d of x. Alex might call that d of x. Why would they call it a d? Use the letter d. Because that's doing the dividing. That's right. And so what I want you to do is write out 2x minus 5. And then outside the house or whatever you want to call it, the division symbol there. And underneath the house, we'll write in our dividend. That's the actual word. But the equation f of x. So which is 6x cubed plus 17x squared minus 104x plus 60. I'm going to walk you through the steps of how we do long division. It's the same concept of what we were just working on, except for we got to detail how do we get started. Here's the first thing you're going to do. You're going to divide the leading term of f of x by the leading term of the divisor, which is d of x. So that's going to be our first step. So question for you, as you look up here, what is my leading term of this function in here, this f of x? 6x cubed. Don't write this red arrow yet. I'm just pointing out that's the leading term. And what's the leading term of the divisor? 2x. And so we're going to divide those. Now, a lot of people know exactly how to do this by this stage. A lot of the time you get to pre-cal, but in case you don't, 6x cubed up at the top of the screen. All right, what is 6x cubed actually? 6x cubed is 6 times x times x times x. And we are dividing that by 2x, which is just 2x. So how I write this out is like this. What is 6 divided by 2? 3. Now, some teachers don't put it in this location, but I do. Since I'm dividing this 6 by this 2, I'm going to put the 3 directly above that 6. And now you have these x values here. What happens after you simplify those x's? What are you left with?
2x.
The 2x's. Now, would I write that as 2x or x squared? X squared. I'm going to put that right above the x cubed because that's where that came from. Now I'm going to erase these arrows because I told you you don't need those. So now that brings me to the second step. What do we do from here? Well, if you remember on this little basic thing, I said we multiply these numbers. Here I have a group. So when you multiply a group, it's called distribute or distribution. So I'm going to distribute. So this 3x squared is going to multiply with 2x and also with negative 5. You're correct. Was that Vanessa? 2x times 3x squared. What is 2 times 3? 6. And as we just discovered up here, it should be getting the same thing. We have 1x, 2 more x's. How many total x's is that? 3. That's 3 powers of x. Okay, but we don't just multiply the 2x times the 3x squared. You also multiply negative 5. What's negative 5 times 3x squared? Good. Negative 15x squared. Great. So now this is the step. Some students don't distribute that. There is a percentage that make that error. This is the third step, is the step that most students, if you're going to make a mistake, it's right here. The third step is what I call the fundamental rule of division, which I'm not going to write it that way because that would make no sense for notes. What I'm going to say is we change the signs, and then combine our like terms. So change signs and combine. If you want to write out combine like terms, go for it. But what I'm going to do the rest of the day is change signs plus combine. So here I go. These are the terms of combining, but I'm going to change the sign. Right now it says positive 6x cubed, so I'm going to make this one become negative. And this is a negative right now. So we're going to make that become positive. So I changed those signs. And now I'm going to combine my like terms. I'll simplify. So 6x cubed and 6x cubed cancel out. And now 17x squared plus 15x squared is 22. Good. They combine and they give us, I hear, 32x squared. Good, Vanessa. Good, Aaron. Good math. Step 4. Here, bring it down. I call it drop. Drop and repeat. Drop plus repeat. So what do I mean by drop? This negative 104x, that's the next term that we have not used. It drops down. So negative 104x. And now I repeat. So back on up to step 1. The leading term of f of x divided by the leading term of d of x. Well, the leading term of f of x has been changed. What is now our leading term of f of x?
32x.
You got it, 32x squared. And it's going to get divided by 2x. Now I'm going to erase this for a moment because I don't need that arrow anymore. So up at the top, 32x squared, this is a reminder, means x times x. And that's getting divided by 2x. So the x's simplify. What is 32 divided by 2? 16. And since I'm writing it in line with this column, I'm going to put it right here. So it makes a complete column. 16x to the first power. There's only one x left over up there, so it'll be 16x. So that's step 1. I took my leading term and divided by my leading term. Okay, step 2. I now distribute. So I'm taking this 16x and I'm multiplying it by 2x and also by negative 5. What is 2x times this 16x? What is 2 times 16? 32. And this x times this x gives us x squared, x to the power of 2. Very good. Now we also, because we're multiplying, I need to distribute. So what is negative 5 times 16? Oh, some mental math champions in here. Negative 80, I agree. And how many powers of x? Just one. That takes us to step 3. We're going to change our signs and combine like terms. Negative 32x squared, I agree. Good, Mason? Plus 80. You got it. So these simplify out of there. And now negative 104x plus 80x. Negative 24, great. Negative 24x. And now, since I combine my like terms, it's all that's left over. I get to step 4. It says drop and repeat. This will be the last time to drop and repeat, because 60 is the last value I can possibly drop. So here we go, one last time. Let me erase my previous step 2, the distribution. All right, let's start all over. One more time. It says to take the leading term of f of x divided by the leading term of dx. What is my leading term of f of x now? Negative 24x, and it's going to get divided by 2x. Shouldn't have shifted down yet. We can go back up to the top one last time. Negative 24x divided by 2x. The x's simplify. What's negative 24 divided by 2, Natalia? Negative 12, I agree. So again, I'm writing it in this column. That's how I do. So if you go search YouTubes for other teachers, they might group them by columns, but I think it's easier just to do it the way we've been doing since 3rd grade. So I try to just do things the same way. Honestly, it doesn't matter where you put it. Now I distribute. Step 3, or excuse me, step 2. What is 2x times this negative 12? Negative 24x. Great. And what is the negative 5 times negative 12? Positive 60. All right. Step 3, the last step for us. Change signs and combine like terms. So this again is what I call the fundamental rule of division. If you hear me say that, it's to change the signs. This becomes a positive 24. This becomes a minus 60. I can simplify these terms. And I simplify these terms. What's left over then? 0. That means that our remainder, r of x is what I'll call it for a remainder, is 0. This tells us 2 very important things. If your remainder is 0, this tells you what you divided by. In this case, 2x minus 5. 2x minus 5 is a factor. Is a factor of this equation f of x, since the remainder equals 0. If your remainder is 0, it's a factor. And as you learned last class, if something is a factor, that means it's also a 0 when you solve for the x. So let's solve for the x here. If I wanted to solve for x, I would say 2x minus 5 equals 0. What would be your first step? Plus 5. Great. This is why we typically say inside lies. The inside with x's, because when you solve them, everything goes opposite. So instead of it being a minus 5, now it's 2x equals positive 5. And then what's our last step from here? Divide by 2. So when we divide by 2, we found a 0. X equals 5 divided by 2 is a 0. Does anybody know what that is as a decimal?
8.5.
Yeah, because we're going to look at a graph in a second, so you know that value is a 0, an x-intercept. That's an x-intercept. All right, so this technique that we just did right here is called long division. Any idea why we call that long division?
It's forever.
It was long, pretty self-explanatory. Sorry. So that is long division for you. I do have I'll call it a cheating technique, although it's not technically cheating, that I'll show you in a moment, but I want to walk you through. It was a 4-step process that was repeated multiple times. And the very important thing is right here at the bottom. When we got that 0 is a remainder, it told us 2 things. What are the 2 things it told us? That the original thing we're dividing by is a factor. And secondly, that factor will generate a 0 for us. Okay, now back up to the problem. It says factor this equation completely. Here's what that means. To continue factoring until you found all of them. Well, there are still more factors out there. What I need to do is look at the quotient. I didn't even label this right up here. This value, this quotient, I'm now going to rename this here, this quotient, I'll call it Q of X. The quotient, Q of X here, has two more factors. I know that because there's a second power of X. So there's two more factors in there. I don't have to use long division though now. This is now a trinomial. What technique have we learned to factor trinomials? X method. So off to the side over here, I'm now going to do X method on the quotient. So step one, what was step one when you do X method? GCF. So I'm going to take the GCF of our quotient. Does our quotient have a GCF? Can 3 go into 3, 16, and negative 12? No, which one does 3 miss on? 16. Can't go in there. There's none. So the first day of school, we said n-a, or there's none. It's not applicable. There's no GCF. Okay, the second step for X method is where you actually do the X process. I'll just call it the X method here. I'm going to draw an X. At the top of X, I put the A times C value. At the bottom of the X, I'm going to put the B value. So let's label these A, B, and C. Okay, thank you. So what is 3 times negative 12?
36.
Negative 36. And our B value is 16. And if you remember how the rest of the way what we did the first day is I labeled these M and N. It doesn't matter what letters you use, but ultimately we're looking for two numbers that'll multiply to be 36, but either combine to be 16 or have a difference of 16. And we'll figure out the negatives in a little bit. So if you need a technique, you can write out a T-chart. What are different factors of 36 you can think of? I hear 36 and 1. I agree with 36 and 1. I heard that. I heard 6 and 6.
18 and 2.
18 and 2. Okay. I heard 4 and 9. 12 and 3. That's all of them. You got them all now. All right. Looking over this list, which one could either add to be 16 or if you subtract could be 16? 18 and 2. Those are going to be our numbers. Which one is it, adding or subtracting? Subtracting. What are we subtracting? 2. So it's going to be 18 minus 2. All right. What was step 3 in this process? Split the A terms power. Split. And I started just saying split A, but since it's been a long time for the notes here, I'm going to say split A terms power. Split A terms power. So what I do is I come up over here and I'm going to take the A term that's right here and split its power. So its power is a 2. When you split the power 2, what are you left with? Just power 1. So it'll be a 3x in one parenthesis and a 3x in the other parenthesis. So I split the A terms power and I include the two numbers from our X method. So the plus 18 and the minus 2. We have one step left. What was our last step? Simplify. Good. Step 4 was to simplify. And you have to do this anytime your A is greater than 1. Our A is 3 here. We have to simplify. Which factor gets simplified? The front parenthesis, the back parenthesis, or both parentheses? Just the front. What goes into both numbers? 3. 3 is all that goes in. So when we simplify it, we find the last two factors are x plus 6. That's the front factor here. And 3x minus 2. So we've now found all the factors. Those are factors there. 2x minus 5 was another factor. So here's our factored form. The original equation I called f of x, so I'm going to call it f of x again here. F of x could be written as the factor 2x minus 5 times the factor x plus 6 times the factor 3x minus 2. That's factored form. So we have just completely factored it. And now, just to be extra, what zeros would exist? There'd be 3 zeros here. We already found this one. This one we said was x equals
5 divided by 2. We added 5, we divided by 2. What 0 would be generated if we solve this factor? -6, that one's easy. And what about this one? Y'all are good at this. You would add the 2, so it'd be a +2. And then how do you get rid of a 3 that's multiplying? Divide by it. Okay, so writing all this out, you might be wondering, why did he write all this out? He didn't ask for zeros, because this leads us into a huge shortcut. If you understand that factors and zeros work together. Hey, medium. Medium. So let me show you the graph. Whoops. Here we go. Here's the graph of this equation. I've graphed it here. How many zeros do you see in this on the picture of the graph? 3. So what I'm doing here is I'm pausing the algebra, and I'm going to show you a way to quote unquote cheat, which means how could we have done this without going through all this work? If you looked at the graph first, it has 3 zeros. Their locations are -6, 667, and 2.5. Those are our zeros. Well, what you would do first is make sure that all the values, if they're not a whole number, you would get them as a fraction. So what I'm going to do is type in these zeros. Now, if I type in 0.667, which is this 0 right there, a fraction button pops up. If I press it, it'll say it's 667 divided by 1,000. Well, I'll tell you, that'll never be your numbers you're working with. This 0.667, the Desmos has rounded. Does anybody have any idea what that decimal should be if it's unrounded? 2/3. And it's just going to be a bunch of 6s repeated. So what I'm going to do here is to take away the 7, and I'm just going to type in a bunch of 6s until here. You see how it automatically went to 2/3? That's the fraction I'm going to work with. Now, if you're paying attention, that's this value right there. -6 is already shown to us right there. And now let's do 2.5. 2.5, you hit the fraction, it says it is 5/2. Okay, so if you were only using the calculator, how could you do all this work that I've just shown you right here? Here's how you could do it. Let me get a new page. You would graph, and you would find the zeros. So here's the calculator cheating way, is graph and locate zeros. Graph plus locate zeros. When I did so, we got the zeros -6, 2/3, and 5 divided by 2. Cool? Step 2, separate the zeros individually. So just find some space to write this down. I'm sorry, you might be limited, but I'm going to write this as x equals -6, x equals 2/3, and x equals 5/2. Step 3, turn zeros into factors. But no fractions. It's very important you got this. No fractions. So that'll change how we solve. So let me talk about how we turn this 0 into a factor. You take x equals -6. To turn it into a factor means you set everything on one side and get this back to where it's equal to 0. So what is the opposite of subtracting 6? You would add 6. And so I would have x plus 6, and you just put it in parentheses, x plus 6. There's one factor. You don't set it equal to 0 with any factor. You just leave it like that. I do it over here. I do this again. Now here's the deal. I say no fractions, which means I don't do the opposite of 2/3. Opposite of 2/3 is -2/3. I don't do that. I have to get rid of the fraction. So if I want to get rid of the fraction, what is the opposite of dividing? Multiply. So I multiply both sides by 3. This gives us 3x equals 2. I'm almost done. What's the opposite of 2? -2. So I subtract 2 from both ends. Will this become 1x? 3x minus 2, does that become 1x? No, it's just, they're not like terms, so you just keep them separate. This is the factor 3x minus 2. Okay, now I'm going to do this one. this 0. The 0 is 5/2. Again, no fractions, so I gotta get rid of the fraction. What is the opposite of dividing by 2? We multiply both sides by 2. So 2x equals 5. Now, to finish this as a factor, I gotta get it equal to 0. What is the opposite of 5? I subtract 5 from both ends. So I'm left with 2x minus 5. Okay, whether you realize or not, what I was just doing is I just came up from the graph. From this graph, all I did is I typed it into the graph. I located the zeros. I graphed and located the zeros. I turned those zeros into a fraction though. I separated the zeros individually, and then I turned them back into factors without leaving anything as a fraction. What did this do for me, these 3 factors? What it did is this entire page of work right here, which it is some work, but this entire page is what we did here. Now, which one was less work? This page or this page? We'll call it page 1 or page 2.
Page 2.
Page 2 was a lot less work because this one, half of it was just me writing. And we got the same answer that's written right there, just by using graphing technique. Okay, so here's what I want you to do. Your first DOL, I want you to try, not the algebra yet. I'm gonna do another one of algebra because I think you need to see 2 algebras before you do a long division. I do want to see if you can do the long division shortcut that I was just showing you. Whenever you're just factoring, I want you to graph and see if from the graph you can come up with the correct factors from here. DOL number 1. All right, let's look at example 2 here. And this time I'm going to reload and not do the calculator this time. I'm only going to do long division just to show you this one more time. So using long division, what you would do is you would take your divisor here. I'll call this d of x, and we're going to take our divisor, x squared minus 5x plus 6, and we're going to divide that into this dividend here, which I will call f of x. X cubed minus x squared minus 14x plus 4. All right. Angela, how about Angela? Do you remember what step 1 was? It is the division. The leading term divided by leading term. This time I'm just going to say LT divided by LT. What does LT stand for? Leading term. What is my Rico? What's my leading term right now across here? That's right. Take the highest powered term. It's x to the 3rd power divided by x squared. In case you're not sure, x times x times x, that's x cubed. And you're dividing that by x squared, which is x times x. When you simplify that, what's left over? X. So we're just going to put an x there. Now step 2. Step 2 was, Keyshawn, do you remember?
It was to distribute.
Distribute, that's right. Distribute. So every value in the divisor gets multiplied by x. So I'll just do it this way. What is x times x squared? X cubed, that goes there. Okay, now I'm going to multiply this x. Now I'm going to multiply this x times negative 5x. Negative 5x squared, good. And now I'm going to multiply this x times 6 plus 6x. Good. Step 3. Change this. I hear Keyshawn saying it. Joseph, what do you think? Change the signs. And I'm just going to say combine, but what else should I write if I were going to write everything out perfect? Combine like terms. Thank you, Pedro. So we're going to change our signs here. Negative. What happens to this negative? It becomes a positive. And what happens to this positive? It goes negative. All right. X cubed minus x cubed is nothing. Negative x squared plus 5x squared 4x squared. We're saying positive or negative on that?
Positive.
Positive, I agree. Now I have a negative 14x and a negative 6x. Negative 20x, good. Which takes us to step 4. All right, Angelin, what do you got on this? Drop and repeat. Drop and repeat. So this time we only have to drop one time. There's only one number that drops that we haven't used yet. It's the +4. So I dropped the +4 and now we repeat. Back to the leading term divided by leading term. 4x squared is my new leading term. It's going to get divided. Let me erase this to get ready for 4x squared is going to get divided by x squared. So I'll go up top. 4x squared. That's 4xx divided by x squared. xx. Can you simplify? The x's cancel out. What are we left with?
4.
Just a 4. Just a 4. So it's a positive. So I'll put a +4. Step 2. We need to distribute. So each term is going to get multiplied by 4. So here we go. Multiply. What's 4 times x squared? 4x squared. Now I multiply 4 times negative 5x. Negative 20x. And finally, 4 times 6. 24. Fundamental rule of division.
Change the signs.
Thank you, Aaron. We change the signs. So that becomes negative. This negative becomes positive, and the positive becomes negative. These simplify. These simplify. 4 minus 24 is negative 20. This, what do you call the negative 20?
The remainder.
The remainder. So this right here, is it a factor or not a factor? Good. This is not a factor. Not a factor. Honestly, I should say x squared minus 5x plus 6 is not a factor. Not a factor since the remainder does not equal 0. And if it's not a factor, what else is it not? Very good. Not a 0. Is that Kaya? Good work. Not a 0. So if you graph this one, this would not hit the x-axis. Well, that's not even a location there. But it's not a factor. One thing, if you're doing this on Alex has, at least in the past, it could have been updated this school year, but in the past, there's some problems where they ask you to write, they'll say q of x equals, and it'll just give you a field to type it in. If that were the case, what would you put in this field for q of x? X plus 4, that would be an answer. You'd say that is x plus 4. And then it'd have another field that would say r of x equals. And what would you put in that case? Not undefined. It would be negative 20. Now they could write it that way. There's also some problems though, where they don't do it that way. Where they give you this field here, they'll give you a field. And then it'll do plus a division line with your divisor in the denominator. And another field in the numerator. Now, if they wrote it this way, what would you put in this field for your answer right here? X plus 4. And what would you put in this field? Negative 20. You got it. So you can see that'll happen both ways. At least in the past, it's happened both ways in Alex. So in one assignment, you'll have some where you write the answer like so, and other problems where you write it in this format. Just know both are acceptable. Okay, you've seen me now do 2 different long divisions. I showed you a graphing technique, which, by the way, the graphing technique only works if it's a factor. So you could have tried graphing technique, it would not have worked here. I want you to try this one here using long division. I'll leave it here so you can see your multiple choice. DOL number 2. All right, so long division, what's your thoughts? Too long? Yeah, it's long. So there's a thing called synthetic. Synthetic means, well, I'm not sure exactly what synthetic means, but I think it has something to do with synthesizing, making things smaller, quicker. Either way, I'm going to show you synthetic now. So let me get your eyes back synthetic division, they call it these 4 steps. I use different steps. So my steps, I'm gonna write a little bit different than this, but this is there in your packet either way to look at. Here are my steps as we go. Step number 1, using synthetic division. Again, synthetic is a shorter way to solve these. Step number 1 is I solve the divisor, solve d of x equals 0. So you can only do synthetic if you can solve the divisor for x. In this case, the divisor d of x is x minus 3. Are we capable of solving this for x? Yes. So you just take x minus 3 and say x minus 3 equals 0. How do you solve that? Plus 3. That's our first step right there. We solve the divisor is equal to 0. So we get x equals 3. All right, step number 2. On step number 2, I'll write it out as when we set up everything, we check for missing powers. And I'm about to explain what this means. Check for missing powers as you set up synthetic. Okay, so what do I mean by check missing powers? You look up here. So this right here is going to be our second step. You start with your leading term's power. The power is 5. What you need to make sure is you look across, you need to have every smaller power going down from the 5. So do I have a power of 4? Do I have a power of 3? 2? Do I have a 1, which means just an x without showing a number? And do I have a constant all on its own? Okay, I have everything. If that's the case, all you do is you set it up like this. You take your 3 that you're dividing by, and with synthetic division, you don't go up and over. With the division, you go down and around like this. And now you write out only the coefficients. So when I write out the coefficient 2, followed by -4, -3, -6, -5, and -8. Some of you may have done this in Algebra 2. Others did not. Just depends on your teacher. I'm going to leave a gap and then draw a line across. We're going to have to fill in numbers here, so make sure you leave yourself a space. From here, step 3. Step 3, call it following your mama. I'm going to write down mama. Yeah, you follow your mama. And we don't actually, well, you should follow your mama. That's the right thing to do, in general speaking. But what do I mean by that is this. After you drop down, you're going to drop down this number 2. Mama stands for multiply, add, multiply, add. And honestly, you're going to just keep on doing that until we finish this problem. So you start with M. What does M stand for in math? Multiply. What's 3 times 2? 6. Now that I've multiplied, you add these together. What's -4 plus 6? 2. That goes there. Now that you've added, you return and repeat. You multiply again. What's 3 times 2? 6. Now we add. -3 plus 6 is 3. Now we repeat. What's 3 times 3? 9. Now you add. -6 plus 9 is 3. Good. 3 times 3? 9. -5 plus 9 is 4. Y'all good. 4 times 3 is 12. Now we add. -8 plus 12 is 4. Now, the last number is always your remainder. Your remainder, you need to catch this, will never change. Now, this is important because there's going to be a 4th step where these other numbers can change. This part of the quotient can change. The remainder never changes. So is this a factor or not a factor? Not a factor. Would x equals 3 be a 0 or not a 0? X equals 3 is not a 0. Okay, so to finish up synthetic, there's a 4th step. Step 4. I usually write it right up here. Step 4 is you divide the quotient by whatever coefficient is in front of x right here. In this case, how many x's do I have? Just right there. I just have 1. So everything would get divided by 1. And the other conversations, Can we rein those in? Thank you. So all these would get divided by 1. When you divide by 1 though, does anything change? No. So this one, here's how our, I'll write it right here. Here's how our quotient will look. Hey Mason, Angelique. Thank you. This started as x to the 5th. Whenever you do synthetic, you always drop 1 power down. So starting here, it'll be x to the 4th. So 2 divided by 1 is 2x to the 4th power. And then from there, each value drops 1 power. So that's a positive 2. So it'll be 2x to the 3rd power plus 3x squared. Notice I'm just dropping a power as I go down. Now I'm at this 3x to the 1st power. And finally, 4. That's my quotient. And again, the remainder is 4. Now, as you write that out, that's one way you could see an answer. You could also see an answer in this form right here. Let me redo. I'm just going to copy and paste. You could see an answer written like this, where you write out the quotient plus, and it'll be a blank over the divisor, and you would fit the remainder right there. What's our remainder? 4. You could see it written that way as well. Either one is a correct form of division. I'll just box this one up, but both are correct. Could you use the calculator on this problem? To use that calculator trick I showed you earlier?
No.
No, Keyshawn, why would that not work here?
Because it's not a factor.
It's not a factor. You're gonna use a calculator, it has to be a factor. If it's not a factor, it will not work. Okay, I'm gonna do another before I give you one to try. Part B. Step 1. What was step 1? Solve d of x equals 0. Okay, so here's my divisor. I'm going to take 4x plus 1 and set that equal to 0 and try to solve that. How can I solve this equation? We will divide in a second, but we can do something first. We subtract 1 from both sides. That's the opposite of plus 1. So 4x equals -1. And now divide by 4. Now, if you could use this as a fraction or a decimal, I'm going to use the fraction, but you could do it as -0.25 if you'd like. I'm going to use, for step 2 here, I'm going to use -1/4. Before I start doing step 2, you need to check if it has any missing powers. The leading term, it has a power of 4. Do I have a power of 3 present?
Yes.
Power of 2 present?
Yes.
Power of 1?
Yes.
And no x at all? Yeah. By the way, if you were missing something, you would just put a 0 as a placeholder. So here I have 8, sorry, I forgot to write the division. -1/4 is what x equals. That's what we're dividing by. And it's dividing into 8, 38, 5, 3, and 3. Skip a space, draw your line across, and now step 3. Step 3 was that acronym. What was the acronym? MAMA, which stands for multiplying, adding, so on. The 8 drops to start this equation. All right, start the process. 8 times -1/4.
-2.
It is -2. If you're not familiar with how fractions work, you multiply the numerator, divide the denominator. Just the 1. If you multiply just this 1, does that change the 8? 1 times 8? No. So I'm going to ignore the 1 here. What I'm going to be doing here is basically just dividing by -4. Because multiplying by 1 doesn't change it. So this one, I know it's kind of corny to say this, but instead of doing mama, it's kind of like we're doing dada. Because all we're gonna have to do is divide by -4 each time. So what is 8 divided by -4?
-2.
-2. Okay, now I add. What's 38 minus 2? 36. Good. And now I do reload. Again, multiplying by 1 doesn't change it. So what is 36 divided by -4? -9. You got it. 5 minus 9? -4. And take my -4, again, multiplying by -1 does nothing. So what is -4 divided by -4? +1. 3 plus 1 is 4. Here we go, reload. 4 divided by -4,
-1.
-1. 3 minus 1 is 2. The remainder will never change. So the step 4 I'm about to do, that does not change. So is this a factor or not a factor?
Not a factor.
What about a 0?
Not a 0.
Not a factor or a 0. It's not a factor or a 0. Okay, now step 4. This last one did not need, we didn't have to do step 4, nothing got simplified. Step 4 is when you divide by this number there. Step 4 is you take your quotient, or what looks like it's going to be the quotient, and you divide by this coefficient, which is 4. All my answers need to be divided by 4. And this makes sense. Let me write out the division of 4, and I'll tell you why this makes sense. Just think for a moment. If we tried long division, you would start with 8x to the 4th right there. 8x to the 4th divided by 4x. What is 8 divided by 4? 2. We should have a 2. Right now we have an 8 there. We don't have a 2, do we? So at the very end, and it must be at the very end. You cannot do it earlier. At the very end, you divide everything by that 4 that's located right there. So what is 8 divided by 4? 2. That's going to give us our 2. And something I forgot to write down here. This was a x to the 4th power. So when it drops, it becomes x to the 3rd power. So our quotient is 2x to the 3rd power plus, what's 36 divided by 4? 9. Good. And that'd be 9x squared. -4 divided by 4. -1. I don't need to write the 1 because I can just put -x. It's -1x. And then finally, 4 divided by 4 plus 1. Okay, and now the remainder is 2. If you're wondering, why does the remainder not get divided? Well, here's why. If I were to write it in the other form, if I were going to take that and write the answer in this form, what you would then do is say plus and have that fraction, and it would be in this step right here, where you write 4x plus 1, that the remainder actually gets divided. The remainder would get divided right there in this step. And so, whoops, that's supposed to be a 2, not a 4. Sorry. It'd be right there, it gets divided. So that's why you don't divide the remainder, because if you write it in this form, that's implying it's going to get divided right there. So that would be your answer. With that, I'm going to let you try your third DOL. DOL number 3. All right, taking a look at example 4. Let's reload and do this one more time. Question for you is, you're trying to determine, can I use synthetic or do I have to use long division? What's it based off of? Have I made that clear this class? Maybe I haven't. When can you use synthetic? Answer, when you can solve the divisor equal to 0. That's when you can use synthetic. Can we solve this equal to 0? Yeah, we can. So let's take our 2x minus 1 and set that equal to 0. All right, what would you do first to solve for x? We add 1 to both sides. So we have 2x equals 1. Now what?
Divide by 2.
Divide by 2. So x in this case, we're saying is 1/2. All right, so on step 2, I'm going to check for missing powers as I write this out. Well, first you check for missing powers and then you write it out. So I'm taking 1/2 dividing into. My leading power is a 4. Do I have any missing powers? Yes. What power am I missing? A 3. So what I need to do is include a 0 as a placeholder for x cubed. Otherwise, you will get the wrong answer every single time. So it's going to be 4 followed by a 0 because I had 0 x cubes. Then a -5, a +8, and a 6. So that's what I mean when I say step 2, where you check for missing powers. That's what I'm talking about, is if you're missing a power like that. All right, step 3. What was step 3? Mama, you got it. So I'm gonna draw my line. The 4 always, the first number drops straight down. So it's 4 times 1/2. Very similar to the last example as when you multiply 1, nothing happens. So basically this will be 4 divided by 2. 2. You combine 0 and 2, we add these. What's 0 plus 2? 2. Wrote that before you even told me. Okay. Here, 2 times 1 is again going to be 2, but what's 2 divided by 2? 1. So -5 plus 1, -4. Reload. -4 divided by 2 is -2. 8 minus 2 is 6. And then finally, 6 divided by 2 is 3. Add those together, what do we get? 9. Now that's the remainder, and the remainder never changes. Is this a factor?
No.
Is it a 0?
No.
Would graphing technique work on this?
No.
Graphing technique would not work because it has to be a factor or a 0 for graphing to work. So for synthetic to work, you have to be able to solve for x. For graphing to work, it has to be a factor. Other than that, you have to use long division. This started as x to the 4th. When it drops, it's going to become x third. But if I stop here, I still got the wrong answer. What have I not done? Step 4. I need to. Okay, step 4. We're going to divide by everything by 2. So everything in the quotient gets divided by 2. That leading term there, or the leading coefficient. So we divide everything by 2, and we should have our solution. So in this case, our quotient will, the final answer will become 2x cubed. What's 2 divided by 2? 1. So it'll be just 1x squared, because now we just start dropping the powers. Minus 2x plus 3. And one more time, either remainder will not change because why? Why does the remainder not change? Like, why does it not get divided by 2? That's right. When you write it out this way, it gets divided when you separate it like this. If you were to, let me erase the q of x now. If you were to write it this way, where you set it over the divisor of 2x minus 1, it would get divided right there. So this would be the 9, and you could write the answer in that format. So on Alex, you'll see it in both formats just like that. All right, I'm going to let you try one where you see a missing power. Shouldn't give that away, but I just did. You try this one, DOL number 4. All right, example 5. So on real world problems, you can actually use the same thing we've been doing to solve equations. Like here, it says, suppose 800 units of beachfront property have tenants paying $600 a week. Research indicates that for each $10 decrease in rent, 15 more units would be rented. The weekly revenue from the rentals is given by this function, where x is the number of $10 decreases. I'm going to stop and write that. X is $10 decreases. I always label the values. And the R is the revenue. I don't think it says that, so I'll do it right here. This is R of X. R of X equals revenue. So here's the question. Use the remainder theorem to find the revenue from the properties if the property manager decreased the rent by $50. So that, how many decreases would that be? If we're decreasing by $50, how many actual decreases would that be? What's 50 divided by 10? 5. So X is 5 in this situation. So what we could do, you've learned in the past, is you could plug in 5 as an X value, but you could also, what this theorem is saying is you can plug in 5 or do a synthetic with it. And so I realize I said use the theorem, but I didn't even tell you where the theorem is. The theorem states that if you were going to plug in like an X value, say R of 5, that whatever you get here is the same exact value you would get if you did synthetic division with a 5. So I'm going to prove this to you in a second. So I'll plug in 5 here. And so we could type this into the calculator. Let me pull up the calculator now, and we'll type this in. Let's see what we come up with. So R of X equals -150 X squared. and I'm typing it in with x's, and I'll show you why in a second, plus 48,000. And so what we were interested in is R of 5. And so that's the value we should get. Now, if we do synthetic, we'll get that same value. So I'm now going to do synthetic. And so I wouldn't necessarily recommend doing it this way, but nevertheless you can. So we have negative 150, 1000. We already solved for x. I'm skipping step 1. That technically is step 1. This is step 2. I have no missing powers. Okay, and now I'm going to do step 3, which is my synthetic. I'm going to do step 3 here, my follow mama. So negative 150 drops, and when you multiply that times 5, 5 times negative 1 is negative 5. 5 times 50, I'm doing this backwards, sorry. You multiply, you don't go that in first. Let me erase this, eraser, 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 there it is. So let me erase this. Let's try this one more time. Okay, 5 times 0, that is a 0. 5 times 5 is 25, so we have a 5, and now I'm gonna have a 2 up here. 5 times negative 1. 5 times negative 1 is negative 5, but you had that 2 carry over a 2, so it'd be a negative 7. So we have negative 750 here. Now I subtract 1000 minus 750 is 250, and so now I multiply these. I get a 0. 5 times 5 is 25 again with the carry over 2. 5 times this 2 is 10. Add those, you get 12. So when I add these up, I should get the same value. 4, 8, 1, 2, 5, 0. Now I got to figure out what we did wrong here, why we did not get the same answer. All right, and I found my very simple error here. I typed in 48,000. It's supposed to be 480,000. So let me add one more 0. And when I do, there it is, 481,250, which is exactly what we got right there. That remainder is the answer. And so that's what the remainder theorem states, is that your remainder would be the same thing, the same value as if you plugged in the number. And so just to kind of make a connection here, remember how I've been talking about if this what we'd say is not a factor and not a 0, not a factor and not a 0. And if it were 0, we would say it is a factor and it is a 0, because these two numbers should always be identical. This right here, if you graphed it or you put in a 5, you would get 481,250. And that's why we get the same thing here as a remainder as you would get if you plugged it into the equation. So that's all the remainder theorem states. So now it's your turn to try DOL number 5. Okay, so this slide here, I'm now going to serve as kind of a review here. The remainder theorem states this: if you divide something, that's the factor form. So if you set it equal to c, find out what the c. Let's just write it this way: if you had found out that x equals c and you do synthetic, the remainder would be exactly the same values if you plug the c into the equation. That's what we just did on the last example. The factor theorem: if your remainder is 0, then that the factor is a factor, and so if it's a factor, it's also a 0. And then that's what all these are stating right here. All right, with that, we're going to take now a look at example 6. So what can we do with all this? So it says use the factor theorem to determine if x minus 5 and x plus 5 are factors of this equation f of x. Use the binomials that are factors to write the factored form of f of x. Okay, so I'm going to start here, and I'm going to check if this is a factor. So the first step, remember, if you're going to use synthetic, is 1, you have to be able to solve for x in the divisor, which I can here. The x value would be 5. And so step 2, you'd make sure there's no missing powers. So power 3, power 2, this is power 1, this has no power. So we're good on those. So I write it out. 5 is going to divide into 1x cubed minus 18x squared plus 60x plus 25. I'm going to leave a space. And now I'm going to start following mama. So step 3, mama, multiply, add, all the way down. So 1 drops, 1 times 5 is 5. Now we combine these like terms. Negative 18 plus 5 is negative 13. And now I reload and do it all over again. Negative 13 times 5 is negative 65. I now add, because I just multiplied. So I now add 60 minus 65 is negative 5. And now I multiply, reload, and do it one more time. So -5 times 5 is -25. I add these together and I get 0. So if I got 0, that means this is a factor. If the remainder is 0, then that's telling us this came from x minus 5. X minus 5 is a factor of f of x. And not only is it a factor, if it's a factor, x equals 5 is a 0. Okay, so those are two very important things. Now, because that's a factor, that means this equation f of x could be rewritten as the factor x minus 5 times what's the quotient? What's left over to be the quotient? And this one, I skipped over step 4. That's because step 4 here, when it comes time to do step 4, if your value is a 1 there, when you take your q of x, you divide it by 1, that won't change any of the values. These will all stay the same. So I actually don't even need to do to divide that. But just to make this cleaner, I'm going to go ahead and rewrite this as 1x squared minus 13x minus 5. And what I'm going to do is now a second synthetic. So let me actually do this, just to make sure you're following along. This is the x squared, this would be the x minus 5, and the quotient. What you can do, if this is a factor, we've simplified the equation to here. So any other factors have to come from this equation. So I'm going to do another synthetic, but this time I'm going to use the value x plus 5. So this would be the 0, x equals -5. And I'm going to reload and do this all over again. I'm going to do another synthetic. So here's step 1. This is now step 2, because I'm taking the value -5, and I'm going to divide it. I don't have any missing power, so I'm good. We've already checked that. So I'll draw it. All right, now I'm going to drop the 1. This is now step 3, mama. Multiply, add, multiply, add, multiply, add. Okay, I dropped the 1. 1 times -5 is -5. Combine my like terms, I add those up, I get -18. And when I multiply this, -5 times -18 is a positive 90. So when I combine my like terms, this time I get not -85, I'm sorry, I get positive 85. So this is my remainder. So if you have a remainder, just as a reminder, that means it is not a factor, nor is it a 0. So the closest I can get to f of x being in factored form is to write it like this. Well, this is factor form. It's just not reduced into linear factors. I will have the factor x minus 5, this x minus 5. But we could not reduce this quadratic equation here into quotient. So I just multiply it times that. 1x squared minus 13x minus 5. That right there, it has no real zeros. Okay. Or it might have them, but they might be irrational, which we'll learn about that next class. But either way, these are going to either be imaginary zeros or irrational zeros. But that would be our factored form. Okay, so now let me try part B. Part B, we're going to do this again. This time I make slight adjustments to our equation. Here, again, I have this x minus 5. Which means x would equal positive 5. And so I'm going to take positive 5 and divide it into this equation. And like I said, I just make slight adjustments. I'm checking for missing powers. So it's power 3. This is step 2. Power 3, power 2, power 1. I'm good. So 1x cubed minus 2x squared minus 13x minus 10. And now we'll do step 3. I drop the 1 straight down. So 1 times 5 is 5. And now I add. So I just multiply, now I'm adding. -2 plus 5 is 3. Now I multiply. 5 times 3 is 15. Now I add. -13 plus 15 is 2. Now I multiply, reload, and multiply again. 5 times 2 is 10. And I add. -10 plus 10 is 0. That's my remainder. This is a factor. So x minus 5 is a factor. And x equals 5 is a 0. Now, like I said before, if this started x cubed, any remaining factors has to come from this quotient, the q of x. And I'm skipping step 4 again. I shouldn't be. Step 4 is you would take the q of x. Step 4 is you take your quotient and you divide it by 1, which in this case doesn't change anything. Now I could have just started synthetic from right there, but since I kind of messed it up, let me rewrite those. So now I'm going to do the synthetic and I'm going to try on this value. So once again, I'm loading up and I'm going to say x equals -2 this time. So I'll take -2 and I'm going to divide that into this trinomial. So let's now do step 3 here. Go mama. I didn't write the step 4. I should have put that right there. Step 4 as well. Okay. So the 1 drops, and you multiply 1 times -2 is -2, 3 minus 2 is 1, and 1 times -2 is -2. We get a remainder of 0. So we have another factor. So this tells us this -2 came from the x plus 2. So x plus 2 is a factor. And x equals -2 is a 0. This -2 is a 0 because we got a remainder of 0. Now, one more time, I need to do step 4 here. Step 4 would state that you take your q of x, your quotient, and you would divide that by 1 because that's my number right there. So these would both get divided by 1, and this quotient here is my last factor. So it was x squared. When it drops, it becomes an x. So this is the factor x plus 1. So my factored form, if I were to write this out, f of x would equal this x minus 5. That's the first factor. Second factor we got is x plus 2. This right here would be the third factor. From right here. This x plus 1. And so this is the factored form. Now, to go full circle from where we started with the calculator shortcuts at the beginning of the day, so I'm going to graph this to show you using the graphing, since these were all remainders of 0, that you could have graphed this and gotten these same zeros, or it's gotten the same factors from the zeros. Let's check that out. I'm going to graph this equation. So I have f of x equals x cubed minus 2x squared minus 13x minus 10. And when you check out where this graph crosses the x-axis, you'll see that you get zeros at -2, -1, and 5. -2, -1, and 5. Let me write these in. -2, -1, and 5. That's where those zeros came from. And so if you were using graphing technique, you could have gotten the zeros and then changed those into factors. Now you have a DOL to try. You try DOL number 6. All right, let's finish this lesson up with some ACP preparation. So how might this look on the ACP? Well, what if it asks for the remainder given this polynomial function divided by this polynomial function? Well, I could use synthetic because I can solve for x. So I would look at this and do my 4 steps. I would first say, okay, if x minus 2, if I can solve that, I could just say x minus 2 equals 0, which would mean that x would equal 2. And I would use that as what I divide by. And now step 2, I need to make sure I don't have any missing powers. X to the 4th, 3rd, 2, 1, none. So that's good. So I have 1x to the 4th plus 3x cubed minus 4x squared plus 5x minus 7. Step 3 is I'm going to follow pattern mama, meaning multiply, add, just keep repeating that all the way down. So the 1 drops. So 1 times 2 is 2. 3 plus 2 is 5. You add those. Now I multiply. 2 times 5 is 10. I add. So 10 minus 4, or -4 plus 10 is 6. 6 times 2 is 12. Now we add. And I get 17. And now I reload one more time. 2 times 17 is 34. We add. -7 plus 34, or 34 minus 7 would be 26. That's my remainder, which means it's not a factor. It's not a 0, but we don't care about that. All we care about, what's the remainder? The answer would be 26. It doesn't matter where you put these, whether you put them at the front or the back. That does not matter when you fill this in. You could put it anywhere on here. I'd recommend either doing it at the front or the back end, and you don't have to do the positive either. You do, if it were negative, you would have to do that, but you don't actually have to put the plus. And let's spiral review one more problem as well. It says if f of x is that equation g and h, what is h of f of g of -2? Well, these symbols here, when you see the 0, it looks like O's. They're not zeros, they look like O's. That in math means to substitute. And so the technique I give for this is to stack. I'm going to stack h's equation. Let me actually write it this way. H equals x minus 2. F, which equals 3x plus 2. And then the g, which is 2x squared. Now I'm trying to find with an x value of -2. So what I would do here is I would start with x value being -2. And I'm going to substitute that in. What that means specifically, let's see if it'll let me shift this over here. When I stack these up, is I'm substituting in for this x. I'm substituting -2 in for x right there. So I'm actually finding, technically speaking, g of -2. And so when I plug that in, according to PEMDAS, you have to square first. So -2 times -2 is +4. Being multiplied by 2, and you get 8. So for a domain value of -2, it produces an output of 8. Well, so how does it work when you have this composition of functions? Well, you now take this range value of 8, and you're going to plug that into f of x right here. So this x is going to get replaced by 8. So now what I'm finding is f of 8. So I'm no longer finding -2. The -2 produced a value of 8. I'm now finding f of 8. And so this would be 3 times 8. 3 times 8 is 24. And I'd add 2 more, and I would get 26. So now I need to do this one more time, find my solution here. So I'm now going to take this 26 and substitute that in for h right here into the x equation and h. And so now I'm finding h of 26. So notice I'm not finding h of -2, I'm finding h of 26. So it'd be 26 minus 2, which equals 24. That would be your solution. Now, if you want to write it all the way out, you could rewrite it and just say h o f o g of -2 equals 24. That is because the original domain was a value 2, and the final output, the final range, is 24. You could also graph these if you wrote these out like this. H of x equals x minus 2, f of x equals 3x plus 2, and finally g of x equals 2x squared. If you write all those out, you wouldn't need to see the graphs, but you could write out the algebra now. What we would be doing is taking the f equation into the h and the g equation into the f, and so you could type that in literally like this. Let's see if I can get it where you can see them all. You type in h parentheses, and what got substituted into h's equation, if you remember, was f's. But f had something substituted into it. It was g's equation. But g had something substituted in for x. It had -2 plugged in. And so you could also get 24 that way.